let's look at the idea of standard deviation. Here I have two data sets I want to consider that I'm calling data set 1 and data set 2. We can see that these two data sets actually have the same mean, the same median, and the same range. However, they are very different data sets. To distinguish them, we want to look at how far, on average, values are from the mean. We can double check this, but the mean for both of these data sets is 5. So I want to see how far the data values are from this mean of 5. Let's start with data set number 1. We want to find the deviations. In other words, we subtract the mean from each of the values. We already said the mean was 5. 2 minus 5 is negative 3. 4 minus 5 is negative 1. 5 minus 5 is 0. 6 minus 5 is 1. And 8 minus 5 is 3. At the bottom here, we have a dot plot of this data set. The mean is marked by this vertical dotted line. And the horizontal lines represent these deviations we just found. And if we try to average these deviations, we can see that their average is 0. So the average of the deviations here is 0. Let's consider our data set number 2. Once again, we want to subtract the mean, which is 5. 2 minus 5 is negative 3. 3 minus 5 is negative 2. 5 minus 5 is 0. 7 minus 5 is 2. And 8 minus 5 is 3. We can also build a dot plot and show the deviations here, just like we did for the other problem. And we can once again see that these deviations, the average of negative 3, negative 2, 0, 2, and 3, is 0. This phenomenon is not unique to these data sets. If we try to find the deviations of any data set and then average those deviations, we will get 0. This tells us that talking about average distance in this manner is not a productive line of reasoning. However, we can modify our definition slightly to help with this idea. The first way we might do this is to take the absolute value of the deviations. In other words, we could look at 3, 2, 0, 2, and 3, and look at the average of these. This is known as the mean absolute deviation. While this is a valid measure of variation, we will consider a different and more useful way to deal with this. Here I have my deviations from my two data sets. And rather than looking at these deviations, we're going to square each of these deviations. That would give us for our first data set 9, 1, 0, 1, and 9. For our second data set, 9, 4, 0, 4, and 9. Since multiplying two negatives gives a positive, there will no longer be negatives to deal with, so our average will no longer be 0. While there is a little more to it than just averaging the squares, this does help us get started with this line of reasoning. After we make the appropriate changes, this method is known as the standard deviation.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.